Archiving started.
Hello. Today we're going to be looking at Chapter 6, and we're going to continue talking about what we started last week with stored program units. And so we're going to look at our second type of stored program unit today. Obviously, last Chapter 5, what we covered were procedures, which were our first named stored program units. So functions are our second type that we're going to look at. And then after spring break, we will be taking a look at packages and then triggers, which will kind of round out our named program units. So functions, we're going to start talking about those. Now, we've been using functions actually since CIT171. We introduced functions. Basically, they do jobs for us. Okay, so they execute and they perform some type of task. Now, we were using the Oracle provided built-in functions last semester. So the difference with us this semester is we're going to learn to write our own functions to do custom tasks for us in our environment. So if we look here at Introduction to Function, the slide I have up, it talks about a function is similar to a procedure in that it can accomplish a task, just like a procedure can, and it can also retrieve and return values. So we can have both inputs into the function as well as one output. Now, the biggest difference between functions and procedures is really how they're called. A function is part of an expression, so it's not an entire statement by itself when you're actually using it. So a procedure, we could call the procedure, and calling it is its own line. But with the function only returns one value. So the function is actually called as part of an expression, as we'll see in a few minutes when we look at some examples. Now, the other thing that's really unique about functions is that we can call functions from a PL/SQL block, like we've been learning, but we can also call them from SQL statements, just like we did last semester. If you remember last semester we used the Oracle supplied functions, and they list a couple here, like the round or to care. Those are two great Oracle supplied functions. Well, if you think about how we used them last semester in just plain SQL statements, so like a select statement. So we can do that, and we'll look at some examples. But procedures cannot be called in a SQL statement. They can only be called in a PL/SQL block. So that's another key difference between a procedure and a function. So to kind of summarize, where a procedure can return lots of different values, as many out parameters as you want to set, a function typically only has one out parameter. It's a return. We use a return statement, as you'll see in a minute. The other difference is that a function is called as part of an expression, so it can't be standalone. The procedures can be called, and it can be a statement by itself, as we did last semester. And then lastly, functions can be used in both PL/SQL and SQL statements, where procedures can only be used in PL/SQL. So some key differences there. You need to be familiar with them. Let's look at an example of an Oracle supplied function. And we can see here how it's used in both a SQL block or SQL select statement as well as a PL/SQL block. So if we look here at the SQL call for this function, we've got select. We're selecting out the product ID, the price, and then we want to round the price with 0 decimal places. So you can see to actually call the function, we just give the function name, and then in parentheses we put the actual parameters that we want to pass to the function. Very similar to the way we would pass the parameters to the procedures. So here, if we see we've got round price, comma 0. And the two parameters that are going in, basically the price is obviously the subject of what we're going to round, and then the 0 indicates how many decimal places. Okay, So we can use it right here in a SQL statement. Now, if we look at the PL SQL block where we use it, again, the function can't be called by itself as a procedure can, so it has to be part of an expression. And in this case, what we're doing is we're going to set a local variable amount to equal to this rounded value. So you can see that we have the function on the right-hand side of an assignment statement to call it. When we call our own custom functions, we will call them in very similar ways to this. It's just that Oracle wrote these function like the round function for us. With our custom functions, we write them and give them our own name, but they're actually function, or they work they work exactly the same as the built-in functions as far as when we call them. Now, if we look at the create function statement here, you can see the syntax is actually very similar to the create or replace procedure statement. So we've got create or replace function, and then we give the function a name, and then we list our parameters, and for each parameter we have to list its mode and its data type. Now, most of the parameters should be in parameters for a function because we're only going to return, a function's whole job is to return one value. So you can see here we do that with a return variable. Okay, so our parameters are mainly in parameters. If you leave the mode out, notice mode is in square brackets, so it's optional. If you leave the mode out, then it will be considered an in default. Again, going back to what people do in real life, I'm sure some people will leave it out knowing that that's the default. I think it's clear if you include it so that somebody looks at your code, there's no question that those are in parameters. And then let's see, again, just like with our procedures, when we include data type, we do not include sizing information. That's actually gotten from the circumstances surrounding the call instead of doing. You will get an error message just like the procedures if you try to put a size, for example, on a number data type. Now we've got the return statement that declares the return variable, the variable's name and its data type. Actually, it's just a return statement, and then you just give it a data type, actually. There's no name to the variable. Since there's only one, it's the only thing going out. And then again, we use either word, is, or as, whichever you prefer. And then if you need a declaration section, you can have it. If you don't, then you would just have your begin section with your executables. And then you always have one return statement, and that you're returning a certain value. And then you might have an exception section, obviously, and then your end. Now, if we look here at a specific example, shows us a good statement. This one's really simple. It's calculating the shipping cost, I believe. So create or replace function, and then the name of the function is ship_calc_SF. Now, we use the SF at the end to stand for stored function, okay? So that indicates that this is a function. If we needed to look at a list of things, we would know it would stand out to us that it's a function. Then we have one in parameter. We're only going to input the quantity for basically the order, because if you remember, we've done this several times. Our shipping costs are basically based on the number of items ordered. So we have one formal parameter that's an in, and it's a number, it's a quantity, and then we're going to return. And then notice we don't name the variable we're returning. We just put the data type. So that declares the return value. Okay, is, and then we actually want to declare a local variable here because we need to keep up with the shipping number. So that's going to be the actual value we're going to store our return variable in. So we've got local variable shipNum, and it's a number. Because this is a local variable, we can't have sizing information. Remember, it's just the parameters that you can't have sizing information for. So we begin, and we have if the quantity, the order quantity is greater than 10, then our shipping cost is $11. Else if the quantity is greater than 5, then the shipping is $8. For every other order, the shipping is $5. And then we end if, and then what we're actually returning is whatever value we've stored in this local variable. So it's all dependent on this if statement. So we're returning the one variable, and then we end our block. Okay. When you compile this, and we'll go do one live together in a few minutes, but when you compile this, it'll actually tell you compiled. If there's an error, it would give you the error at that point. Compiling it just means that you have saved it and that Oracle has checked the code to make sure that it's valid and that it will work. And then you're not actually executing it when you're compiling it. You're just storing it basically in the database. Okay. And then to actually use the function, we call it from either a SQL statement or a PL SQL block. Now, here is a PL SQL block that's calling our ship calculation function. So we're declaring a local variable based on cost. We're calling it cost, and then we're saying begin the cost equals ship underscore calc underscore SF, and then in parentheses we have to give it the stored parameter, or the actual parameter for the formal parameter, so a 12. So this order has 12 items, and then it says, put line the actual cost. So all we get out was basically the one value that's returned from the function. Okay? So a very simple call to the function. Now, if you try to call a function, we said earlier you couldn't call a function as a standalone. It's got to be part of an expression. Here's the error message you will get if you try to invoke a function like you do a procedure. Actually, it tells you that that is not a procedure, or it's undefined, and so it's not going to work. So you always have to call your function as part of an expression, which most of the time will mean an assignment statement, like you see here. Now, the other way to call a function is to use a SQL statement. And here's a nice select statement that's selecting out the basket ID, the shipping, the actual shipping cost, and then the quantity that we're calculating with our function. So we're basically seeing if there's any discrepancies between what the shipping cost should be calculated as and what we actually charged. And then we're calculating the difference there. So we're actually subtracting out the quantity it should be minus the actual shipping and getting a difference. So you can see here what we're doing is we're basically executing this row by row for each ID basket. So here's a call from SQL. Notice what it's doing is it's pulling in quantity basically from the BB basket for each ID basket. So, okay. Here's another function I thought it was worth looking at for a second. This one is actually just going to return a varchar. So it's basically going to return a string of characters. And basically what we're doing, we're taking in a person's ID number, their first name, and their last name. And what we're returning is actually a concatenation of the word member, space, and then their ID number, dash, then their first name and last name. So basically, maybe this is used to, as it says, to display the member's name and ID number on the screen to the user. So if we look at the output we get, you can see down here in our DBMS output, member 25 dash, and then the person's name, Scott Savid. So that display might be passed to the front-end application and actually displayed on the user screen. So you can kind of see a practical use for a function. Now, using an out mode in a function. I've said this already. We typically do not use an out parameter with a function. Mixing out and return variables can really lead to some confusion. And it also prohibits the function from being used in SQL. With a PL SQL block, you can actually mix in out parameters and have a return value for a function. And it will work, and it's it is legal. But the problem is once you mix that out parameter in a function, then it no longer functions in just a basic SQL statement like our select statements. So you're limiting one of the benefits of a function. If you need to return multiple things, multiple items back to your code, it's best to just go ahead and store it as a procedure. There's really no reason to make it as a function, because you're basically, when you're using these out parameters, you're basically turning your function into a procedure in a way, because you're taking away one of the key differences of a function, which is that functions can be used in SQL statements, but that's only if they return one single value. So make sure you check out that section in the textbook if you're having trouble understanding that. Let's see, multiple return statements. Now, this is something you can also have. We only have one value that gets returned, but you can see how this if statement was constructed. And actually, with the if statement, only one return statement is actually going to execute. So only one value gets returned. This is actually an alternate way. If you remember the other block we looked at a few minutes ago, we created a local variable, and then we had the local variable store the return value based on the result of the if statement. But we could have, you can see this example work just as well, because only one return statement gets executed. And only one value gets passed back. Because if the nature of the if statement is that once the condition's met, then it stops execution and it would exit the if loop, the if statement. So that ensures that we only get one value returned. But keep in mind, if you do use multiple return statements, you've got to be sure you're using it in a construct that will actually only execute one return statement. If you're doing a loop of some type, you couldn't do it this way, because the loop would actually execute the return on each cycle of the loop, and it wouldn't work. So you have to be careful. If statements is one of the times where you could use multiple return statements. Let's see. Now, return statements in a procedure. This kind of goes back to the last chapter, but return statements in a procedure are allowed, but they have a different purpose than in a function. In a function, we actually use the return statement, obviously, to send the value out of the function. With a procedure, it actually changes the flow of execution. So it basically stops processing in the block, and then it basically moves out of the procedure and goes to the next statement. You can use it as a standalone statement. There's a good example in the book, I believe, that shows you one. And the whole thing is that it just halts execution of the procedure. It doesn't actually return anything. What you're doing is you're returning control to the calling block. So if you look on page 228, there's a good example of a procedure that has a return. And in this one, it's basically saying if the SQL row count is 0, then return. So basically, it's an update statement. So they're saying, okay, if there's no row to update, then just exit the procedure. So the return in a procedure functions more like an exit. Okay, parameter constraints. They talk about in this section on page 228, 229, some definitions that you should just need to make sure that you understand. The formal parameter is what actually is in the program unit. So formal parameters are what we declare inside the function or the procedure create replace statement. The actual parameters are the arguments that are used in the program unit call. So basically, when we call a procedure or a function, we're passing the actual parameters to substitute for the formal parameters. Okay, so make sure you understand the difference between the formal parameters and actual parameters. Let's see. The other thing that they point out is that the actual parameters are what actually determine the size of the formal parameters. Since formal parameters aren't allowed to be declared with sizing information, then basically whatever we pass to the procedure or the function during the call is what determines the size. The actual parameters, if they're local variables in our calling block, then they can actually have sizing information in them. I think we looked at an example a minute ago like that. And so then the actual parameters determine the size of the formal parameters. So that's another key point to make sure that you understand. Now, before I get over to SQL Developer and look at some live examples, a couple more things real quick. The describe command can be used with a function just like we used it with the procedure. And when you describe a function, it's going to show you, again, the parameter information. So we have the one return value that's an out parameter, and then the rest of them for this one were in parameters, and it gives you the data type information for each one. So if you don't know much about a procedure or a function, you can use the describe command for either one. Now, for functions, the interesting thing is there's also an Oracle Data Dictionary that you can query, and you can actually pull out the code for the function. So you can view the source code. The name of the data dictionary table is called user_source. So if you select the text column from user source, which is the name of the table, for the name of your variable, so we're saying where name equals memfmt1_sf. So where name equals the name of our function, then we can actually see the code of the function itself. Now, I'll show you in SQL Developer in a minute too. You can obviously do it through the GUI interface in SQL Developer as well. You can actually see the code of the function that we have created. And then just like our drop procedure command, we have a drop function command with the function name, and that will actually delete a function for you. Okay. Now, let me go ahead and get it set up. So I'm sharing my desktop with you. And we'll look at some examples together. Okay, you should be seeing my SQL Developer window now. And I've already connected to my Brew user, and I have actually already run the Chapter 6 script to recreate the database for Chapter 6. So before you try to do any of the examples or the homework for Chapter 6, make sure you do run that script. I left it up just to remind us. Now, we're going to look back and do the challenges together. So let's see, the first challenge is actually on page 225 at the top. Okay, challenge 6-1. It says create a function to return a description for the coffee grind. The input value 3 indicates whole bean, and the value 4 indicates ground. So if the null values provided as input, the function should return NA. And then it says test the function with an anonymous block and also with a SQL statement. And if we use the SQL statement, we're supposed to use the option 2 column as our input. Okay, so let's go ahead and create our function. Now, obviously, I could create a new SQL workshop and we could type everything out ourselves like we did last week with the procedure. But I want to show you an alternate way, and it actually gives us a start with typing our syntax for the function. So when you're using SQL Developer, it is a nice little shortcut. So if you go to File and go to New, where I had been choosing SQL File at the bottom, notice we have some other choices. We can create a new procedure, we can create a new function, or we can create a new trigger. So last week when I was creating our procedures and typing out everything myself, I could have done the same series of steps and just chosen that I want to create a new procedure. But I'm going to create a new function. And it's going to ask me which connection. So this function goes with my Brew user. So then I need to give the function a name, and we're going to call this grind underscore SF. Okay, that's going to be the name of my function. And then I can click OK. And what it does is it opens this new function and it puts in the basic template for my create or replace function statement. Now, if you want it to make it look like we do in the book, you can, put some hard returns in here, and you can also add in what you need. Now, we're going to need an input parameter, so we're going to have to add to this. So it's probably a good thing that I went ahead and added some hard returns. Now, right above the return statement is where we're going to need to put our in parameter. So what we need to do is put in an option number. So I'm just going to call it P underscore option because it's a parameter. Did I get my underscore? P underscore option. And it is a number. Okay. And so we just have the one input. If we go back, it says create a function to return a description for the coffee grind. And it says the input value, we either have an input value of 3, 4, or null. Okay. So we've got our input value. And we have returning, we actually want to return a description. So characters, varchar2 is actually what we want. Now, for this one, I'm actually going to need a local variable because I need a variable to hold the description that I'm going to pass out for the return variable. So underneath my as, I need to create my local variable. So I need to declare it. Local variable, I'm just going to call this the grind description, G for grind. And it is a text local variable, so we're going to call it, use our suffix for text. And it is a varchar2. And we can do sizing for a local variable. So it's going to have a size of 10. Now, if we go down to our begin statement, let's look at what we want to do. We're basically checking for 3 values. We're checking if the input is a 3, a 4, or null. Okay. Obviously, it could be something else as well. So, but probably if it's null, if it's anything else, it didn't really tell us, so we'd probably treat anything else like a null value. So we basically want to test with an if statement our option, our input, okay, our P option. So if P underscore option equals 3, then what we want to do is set our local variable for our description equal to the text whole bean. Okay, because that's what it told us. If the input value is 3, that indicates the text whole bean. Okay. Else if, else if P option equals 4, then we want our description to be equal to the words ground. So it's got ground coffee. And then else we want our description to be equal to NA. And then we need to end if. And then we need our return statement. Now, the default return statement that was put in was return null. So what we want to return is LV underscore G description underscore text, because that's what contains the value that we're returning. And then we have our end statement. Okay. So we should now save this. And then we actually need to compile it. Now, when you execute it, you really don't get much. There's no really reason at this point to execute it. What we want to do is compile. So that what it does is it checks for errors and makes sure that it's functioning, and then it stores it in the database. So if you look up here, we've got the compile button. So we're going to click compile. And in my messages log, I get the compiled message. Okay. So we know that it compiled. Now, to test this, let's go over to our Brew user worksheet. And it tells us to test it two ways. First of all, test it with an anonymous block, and then second, test it with a SQL statement. So let's test it with an anonymous block first. So anonymous block, we've got our declare section. Let's see, we need basically two variables in this anonymous block. One is going to be our input, and one is to hold our output from the function. So we're going to have a local variable, and there will be the option number that we need to provide to the function. And it is a number, size of 1. Remember, these are basically our going to end up being our actual parameters that we're passing to the formal parameters. So the actual parameters can have sizing information. And let's go ahead and assign it a value of 4. So we'll test our function first of all with a 4. And then we need a local variable that will hold the output from our function. So it's a description, and it needs to be the varchar 10. And then we have our begin section. And what we want to do is set our description variable equal to the name of our function, which is grind_sf, parentheses, and then we need to give it the parameter, which is going to be LV_option_num. So we're basically telling it, okay, use this variable and send it to the function. And then all we have to do is output to check to see what we're getting. DBMS output. Dot put line. Whoops. And what we're going to put out is our local variable with that contains our output of our function. And okay, let's go ahead and run this block. Oh, I forgot to turn on my output, sorry. So down in my DBMS output window, I'll click my plus, click OK, and let's run it again so I see my output. So I'll get a ground, okay, and that's correct for 4. So let's change my block to show a 3, and let's run it again. And this time we get whole bean. And then let's put something really random in there, 100, and see what we get. We actually get an error. Oh, the number is too large because it's number 1. Obviously, okay, let's say we put 9, okay, and see what we get. And we got the NA, okay, so not available. So that's good. If we provide it a null value, it should also give us NA, which it did, okay. So all of our conditions in our if statement actually work, so we know that that's good. We tested it thoroughly with a SQL block, or PL SQL block. Now, let's go ahead. I'm going to delete this block, and let's go ahead and test it with a select statement. So we've got select. What we want to do is select out the basket ID. Actually, ID basket item. And then we want to run our function. And our function, if you look back in the challenge, it says test the SQL statement on the BB basket item table using option 2 column as input. So our input for our function is going to be option 2 column. It's from BB basket item. And let's go ahead and clear my script output and in my DBMS output, and let's run this. Oh, I got an error. What did I do? Table or view does not exist. Oh, I misspelled it. That would be why. I need an I in there. Basket item. So let me clear my output again. Let's run it. And so we got 28 rows returned. Let's size my window so I can see this. And for each item, we got our description output. So that's good. So now we know which coffees are ground and which ones are whole bean. And then if it's not a coffee item, then we got the NA. So there's testing it with a SQL statement. Okay. Challenge 6-2. Let's check the time. I've got about 15 minutes left. We can probably do that one as well. It says create a function to calculate the total pounds of coffee in an order. Keep in mind that the option 1 column in the BB basket item indicates the purchase of a half or whole pound of coffee. This column is null for equipment items. You need to take the quantity for each item ordered into account. The input value to the function should be a basket ID. So it clearly tells us what our input to our function should be, and then it's telling us that we need to calculate the total pounds of coffee in an order. So test the function, then test the function with ID basket 3 using an anonymous block. So let's think about this for a minute. We've got our option 1 that says it indicates whether we're purchasing a half or a whole pound. And we're going to have a quantity for each item ordered that we're going to take into account. So basically we need to take the quantity and times it by either 1 for if it's a whole pound of coffee, or we need to times it by 0.5 if it's a half pound of coffee that's ordered at a time. So we're going to need an if statement. And we're basically checking whether the option 1 is either 1 or it is, let's see if we go and look at our table. I believe that if it's 1, the option 1 is 1, set equal to 1, then it's a half a pound. If it's set equal to 2, then it is a whole pound. Okay, so when you think about how we want to do this, now we're going to be actually doing this for multiple items, possibly in an order. So it would be a good idea to do this as a cursor so we get the total number of pounds that are being ordered. Okay, so let's go ahead and create a new function. Okay, now this one we're going to call, let's call it total pounds. It's a stored function. And we were told that we need to take in the ID basket. So let's call our parameter P underscore ID because it's the ID basket, or the basket ID. Whoops. And that is a number. And what we're returning is going to be the total number of pounds. So that's also a number. We're going to return a number. And let's see. We need, in our declaration section, we said, well, there can be multiple items on an order, so we need to check multiple items for that basket. So we need a cursor, so we need to declare our cursor to hold those multiple items. So basically what we're going to have to do is process each item and add the total number of pounds that accumulate the total number of pounds for each item and keep adding in. So we need the cursor. So we're going to do cursor. We've got, let's just call it cur items because we are going to be accumulating items in our cursor. And what we're selecting into our cursor, we need basically option 1 to figure out, and this is from the basket. So we need to know option 1, and we also need to know the quantity that's being ordered for that item. So we're going to select out the column option 1 and the quantity that we're ordering, and we're selecting that from our BB basket item, because our basket item table is the table that contains the individual items that are saved in a basket. And we want that to be where our ID basket, which is our basket ID, equals the P underscore ID, so our parameter ID, okay, the parameter that's passed in to the function call, okay. Let's see, we also need a local variable that's going to hold the number of pounds. So let's call it LV underscore pounds, and it's a number, so we'll call it underscore num, and it is a number, and it's going to have 4 for its precision and 1 decimal place, because we might have 0.5, okay? And we're going to set that accumulator, initialize it, and set it equal to 0 to start with, because for an order, until we know the items, it's going to have a value of 0. Now, in our begin section, I said that we needed to at least have an if statement, but we need to process this cursor and process the if statement for basically every single item that's in the basket. So to do that, the easiest way, at least my preference, is to do a for loop for my cursor, because then I don't have to, remember the advantage of the cursor for loop is that it does the open and the fetch and all of that all at once. So I'm going to use a for loop, and we're going to initiate our cursor and call it rec items, and it's the type cur items, and we're going to loop. Okay, now inside our loop, we need to check that option 1 value, so we know whether we've got a half a pound or a whole pound of coffee that's been ordered for each item. So if option 1 is 1, then we're going to basically times the quantity by 0.5. For everything else, we'll just take the quantity, because it would be assumed a whole pound. Okay, so let's think about this. We also need to check and make sure that option item is not null, because we were told that equipment items have a null value. So we probably want to test that first. And the reason for it is that if equipment items is null, then basically we're not going to do any calculations, okay, for equipment items. So we want to test that first. So let's go ahead and do an if statement that is checking for rec item dot option 1. I can spell right. So we want to check option 1 in our cursor, and we want to make sure that it is not null. Then, okay, so that's the first check. If rec items option 1 is not null, then we can do the rest of it. Now, the rest of the calculation is going to involve 2 cases. So we actually need a nested if here, because if it's not null, then we've got to decide it equals 1 or it equals something else. Okay? That's only two values that it could be. So we're going to do the nested if. We're going to do another if statement. So if rec items dot option 1 equals 1, then what that indicates is that a half a pound was purchased. So then our total pounds, so our local variable holding our pounds, will be equal to, and we've got an assignment statement. So basically, whatever value is still in there, so we've got to do it as an accumulator. So whatever value is currently is, for the first issue of the loop, keep in mind that it'll be 0. But then for the second instance of the loop, it'll take the total for the pounds for the first item and add it to the new total, the pounds for the second item. So that way we keep accumulating and getting our total. So we've got LV underscore pounds num equals LV underscore pounds num plus, now keep in mind we're doing option 1, and that's when it's a half a pound. So we've actually got to take our rec items dot quantity, so the quantity we're pulling out, and we've got to times it by 0.5 because it's a half a pound times the number of half pounds that we purchased, or the quantity. Okay. Now, for this nested if, our other scenario is that it's not 1. Okay. So then our, else, we don't need to test anything else because it's just for everything else. So LV underscore pounds num, and we're going to set that equal to LV underscore pounds underscore num plus the quantity. If you really wanted to be technical, you could say quantity times 1, but you really don't need to do that. It's just complicating things for no reason. So we've got, let's see, it's still got a red squiggly. What did I misspell? I don't see anything I misspelled. Oh, it's because I haven't ended my if. Never mind. So let's go ahead and end my first if, which is my inner nested if. And then we've got to end the other if. And then we need to end our loop. Okay, that finally gets rid of all my squigglies because I've got my inner if ended, my outer if ended, and now my loop ended. Okay, now let's see, we need our return statement, which is already there, but it's returning null, which what we need it to return is actually whatever we have stored in our LV pounds num, and then we need our end statement. And notice they were putting the function name in the end. You don't have to do that. You can just do end like we've been doing. So this should be our total create replace function. Let's go ahead and compile it. And then we'll go over to brew user and let's see, let's test it. Okay. Now, if we look in the book, it tells us that the test the function with basket ID 3 using an anonymous block. Okay, so let's go ahead and create an anonymous block real quick. Declare. We need, we've got an input of ID, and we're going to hold our output of our number of pounds. So we need 2 local variables. And the ID number is a size of 1. and let's set it equal. We were supposed to test it with ID basket 3. And then we need a total number of pounds. And it is also a number, but its sizing is 4-1. Begin. All we want to do is set our pounds equal to our function call, which is going to be our function. Name of our function is total underscore bounds SF. And its input is going to be whatever is in our local variable ID num. Okay, the ID basket is the input. And then all we want to do is do our DDMS output line. And LV, we want to just put out the actual number, whatever our local variable for our pounds is. And we've got our end. Whoops, semicolon. Okay, so let's clear my output and let's run that. And we got 2.5, okay, for our output. So we got a value. Now, if we want to test this with a select statement, come down here. I'll just add it on the same worksheet. We're supposed to use the ID basket that we're selecting out from BB basket as the actual input value. So we're going to select ID basket, so the basket ID, and then we're going to call our function. Whoops. We'll call our function, and we're going to put the input, it's going to be this ID basket. And we're going to select this from BB underscore basket. So basically, we're going to go find this total for every single basket. Now, keep in mind that if you want to highlight or if you want to run just one statement in a worksheet like this, you can either highlight it and click run, or just have your insertion point somewhere in that statement. And when you click run, instead of run work scripts, you click run statement. It'll just run the one statement. Let's see. It doesn't like something. One, two. Let me go ahead and comment this out just to. Okay. For some reason, it was still executing that autonomous block above it. So let me go ahead and show you. Let's clear this out. And I will just delete all of this. We can run it. And so we get the order, the total pounds for each basket. So you can kind of go down through there and see the results. Okay, one other thing I want to show you is under your connections, if you expand the functions, you can see the functions so that we created. If you click on one of them, it will load it. And when it loads it, it pulls up the code. In. So if you need to make changes to it, you can pull it up that way. And without having to retype the whole thing, you can make changes. And what you'd want to do is resave it and recompile it. That way it's the new version's ready to use each time. Obviously, also with since we have this nice GUI tool, we talked about the drop command. You can also right-click and you can drop a function or a procedure or anything by using the right click and then do a drop in here. So it will actually issue the drop for you. Okay, so it's nice features of our GUI tool that we get to use. I think that's all. We've run out of time for sure. I've been going a little bit longer than an hour, I think, or at least an hour. So if you have questions this week with the functions, the homework that you're doing, please give me a call. Or give me a call. I'm sorry. Email me. I would be glad to talk to you if you need to, but we'd have to set the appointment up. But I do have a voicemail in my office if you want to leave me a message for me to call you. But email me is obviously the quickest way to get a hold of me. And like I said, if you are struggling with something on this, I'd be glad to set up an appointment to meet with you online or talk to you about it. I do want you to feel like you can come to me if you have problems or questions with your code. I think the assignments are fairly straightforward. Just pay very close attention like I did with the challenges. Make sure that you name it what it tells you to. It's going to very precisely tell you what should be the input for your function and tell you what the output should be. It will give you information about how to test it in most cases. So, make sure you go through them very, very closely. Read the detail, and they should tell you what you need to know. So I hope everyone has a great week. And obviously we have spring break next week. So if you need me during spring break, feel free to email me. I will try to get back to you as soon as possible. I don't have any major plans, but I know you guys will still be working on some of this if you don't get it done this week. But you do have until 2 weeks, basically, to get everything turned in. So Chapter 6 is due 2 weeks from today. So hopefully you'll take advantage of the time before spring break starts so you can enjoy your time off. Thanks. I'll talk to everyone soon.